Yo, it's me, Anthony Carruthers, and I'll be demonstrating the fact that all triangles that have the same base and the same height must have the same area. So in order to do that, we're using Geometry Sketchpad, and I'm going to start off with an arbitrary triangle. Does not matter how you make the triangle, as long as it has three sides, three angles, you're good. Okay, so there we have a triangle. Next thing I'll do is construct a point above the triangle. And what I'm going to do is make a line that goes through the point and is parallel to the base of the triangle, and we'll see why in a second. So first I'll just select the point, select the base of the triangle, and then construct a parallel line. Okay, what comes next? We're going to take that line and take this point, which is the apex of the triangle, and we're going to merge those together. Okay, so I've created a situation where now I can basically slide the tip of the triangle along that parallel line. We can get rid of this point here, so I'm just going to hide it. Alright, so as we know, when we manipulate this point here, dragging this point along the parallel line, the height of the triangle doesn't change, and also the base of the triangle doesn't change. So what we're going to try to convince students of is that as we're manipulating this triangle, that the area doesn't change. Now, some students will believe that, some won't. So we'll have to give them some evidence. So to do that, we're going to construct the interior of this triangle, okay, by selecting all three vertices. Going to the Construct menu, Triangle Interior. So you can see that when I did that, it basically creates this purple interior region. So that allows me to click on that region and measure its area. Okay, so we can see that the area of this triangle, triangle ABC, is 117.06 centimeters squared, which has no particular significance except for that when I move A side to side, if you look closely, that number is not changing. Now, some students are going to think that this program is just broken, and that's why the number is not moving, because they're used to seeing things move when we move these triangles and other shapes around. So just to make sure everything's functioning properly, and this expensive software I bought is actually doing what it's supposed to do, I'm going to make some other measurements. So here we go. I measure side length AB, side length AC, and side length BC. Okay. And while we're at it, let's go ahead and measure the perimeter of triangle ABC. Okay, so again, I'm going to manipulate A, slide it back and forth. And okay, so there we can see that actually, as I deform this triangle and reshape it, that something is changing. All the side lengths are changing, the perimeter is changing, but the area is still not changing. And we're making the argument that that is because the base of the triangle is not changing and the height is not changing. So if I did want to change the area of the triangle, maybe I could change the base length or change the height. So let's try first changing the base length, and we'll see if the area changes. Okay, and sure enough, as we change the base length, that the area also changes. But if I leave that base length constant now and vary A once again, we'll see that this new area is also not changing. Okay, same for the height. If we manipulate the height, I can make it a smaller height or larger height. In any case, once I choose a new height, I get a new area. But again, if I leave that height constant and the base constant, now that area will not change. So this is a useful fact that students will actually need when they solve problems later on in this lesson. So hopefully this demonstration will at least plant the seed in their mind that anytime you have a triangle, or actually two or more triangles that have the same base length and the same height, their areas will be equal to each other. Okay, hope this helps and hope you found this useful.